Okay. Today we are going to see problems on finding the eigenvalue and eigenvector of a symmetric matrix. So we'll see the problem based on this. Find the eigenvalue and eigenvector for the matrix 0, 1, 0, sorry, 1, 1, 0, 1, 1, 1, 0. That is diagonals are of 0 and the rest of the elements are 1. Also determine algebraic and geometric multiplicity. And geometric multiplicity. So now I will go for the solution for this. First, we want to find the characteristic equation, that is lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Here s1 is determinant of the matrix 0, trace of the matrix 0 plus 0 plus 0, which is 0, trace the matrix. S2 is sum of the minus the diagonal elements which is equal to 0, 1, 0, 1, 0 plus 0, 1, 1, 0 again 0, 1, 1, 0. That is sum of the minus of the diagonal element, which is nothing but 1 plus minus 1 plus minus 1, which is equal to, and this is also minus 1, so we get minus 3. Next, S3, we know the determinant of the matrix, so which is equal to, so expanding the first row we get 0 times, deleting the first column we get 0, 1, 1, 0, minus 1 into, deleting the first row and second column we get 1, 1, 1, 0, plus 1 into deleting the first row and third column, we get 1 0 1 1, and expanding this we get 0 minus 1 into 0 minus 1 plus 1 into 1 minus 0. So it is nothing but 1 plus 1, which is 2. So the characteristic equation is equation is lambda cube minus s1, that is 0, lambda square plus s2 minus 3 lambda minus s3, which is 2, is equal to 0. That is lambda cube minus 3 lambda minus 2 is equal to 0. Now the eigenvalues are the roots of the characteristic equation. Eigenvalues are nothing but the roots of the characteristic equation. So the roots for the polynomial, therefore the roots for lambda cube minus 3 lambda minus 2 is equal to 0. We can use the synthetic division method to find the root for this polynomial. So here I am going to use the synthetic division method, that is 1, 0. The coefficient of lambda square is 0, minus 3 and minus 2. Here I am going to use the error and trial. So if I start with the 1, 0, so 1 plus 0 is 1, and then 1, 1, and then 1, minus 2. 1 into minus 2 will be minus 2. I am not getting the, sorry, I am not getting the denominator is here, it is not 0. So now we try for minus 1. So we try for minus 0, 1 is 1, minus 1 into 1 is minus 1, minus 1 and 1 into minus 1 is 1, minus 2, 1 into minus 2 is 2, so 0, here I am getting 0 here, therefore lambda is equal to 1, lambda is equal to minus 1 is one of the eigenvalue. Now we will find the other eigenvalues. So the polynomial will be reduced to lambda square minus lambda minus 2 is equal to 0. So if you factorize this polynomial, if lambda square minus lambda minus 2 is equal to 0. If you factorize this polynomial, you got it from this other thing. So if you factorize this polynomial, that is lambda square minus 2 lambda plus lambda minus 2 is equal to 0. So again, if you take the lambda common, lambda minus 2, and then I can plus 1, you will get lambda minus 2 equal to 0. So lambda plus 1 into lambda minus 2 is equal to 0. This will implies lambda is equal to minus 1 and 2. Therefore, the eigenvalues are minus 1 and 2. Here the eigenvalues are repeated. Now we are going to find the eigenvectors. Next we are going to find the eigenvectors for each eigenvalues. Okay. So we start with the eigenvalue for lambda is equal to minus 1. First, we will find the eigenvector for the eigenvalue lambda is equal to minus 1. That is a minus lambda I of x is equal to 0. Here x is the eigenvector. So usually for 3 by 3 matrix we take x is equal to x1, x2, x3. So we'll start with this. So a, that is 0, 1, 0, sorry 1, 1, 0, 1, 1, 1, 0, minus lambda is minus 1, so it becomes plus lambda, that is 1 of I, 1, 0, 0, 0, 1, 0, 0, 0, 1 of x1, x2, x3 is equal to 0, 0, 0. So now you have to find the value of x1, x2, x3. So the equation is, so 1, 1, 1, 1, 1, 1, 1, 1, 1 of x1, x2, x3 is equal to 0, 0, 0. So here the equation is x1 plus x2 plus x3 is equal to 0. Here all the three equations are same. Equations are same, and this will represent the equation of the plane. So that is two dimension. So we'll find the eigenvector for this. x1 plus x2 plus x3 is equal to 0. Take x1 is equal to k1. We get x2 plus x3 is equal to minus k1, where k1 is any real number. Any real number. Next, take x2 is equal to k2. Then we get x3 is equal to minus k1 minus k2. Same, where k2 is also any real number. Now the solution will become x1, x2, x3, which is equal to k1, k2, minus k1 minus k2, which is nothing but k1 0 minus k1 plus 0 k2 minus k2. So we should be k1 of 1 0 minus 1 plus k2 of 0 1 minus 1, where k1 and k2 is any real number. Next, we'll find the eigenvalue for lambda is equal to 2. We'll find eigen vector for lambda is equal to 2. So a minus 2I of x is equal to 0. So the equation is 0, 1, 1, 1, 0, 0, sorry, 1, 1, 1, 0 minus 2 times of identity 1, 0, 0, 0, 1, 0, 0, 0, 1 of x1, x2, x3 equal to 0, 0, 0. So we get 2, 1, 1, 1, 2, 1, 1, 1, 2 of x1, x2, x3 equal to 0, 0, 0. So now the equations are 2x1 plus x2 plus x3 is equal to 0. x1 plus 2x2 plus x3 equal to 0. x1 plus x2 plus 2x3 is equal to 0. So we can use the cross multiplication method to find the value of x1, x2, x3. For applying the cross multiplication method, we can take any two equations. Here I am taking the first and second. So we have to start with the coefficient of x2, that is 1, 2, and then x3 will be 1 and 1, and then x1 will be 2, 1, and then x2, 1 and 2. So we start with x2 and x1 and sorry, x3 and then x1, x2, and this will represent this determinant will represent the x1 value, this will represent the x2 value, and this will represent the x3 value. So we get x1 divided by determinant of this 1, 1, 2, 1 equal to x2 divided by determinant of 1, 2, 1, 1 is equal to x3 divided by determinant of 2, 1, and 2, which is a constant k. So now x1 divided by 1 minus 2 is equal to x2 divided by 1 minus 2 is equal to x3 divided by 4 minus 1. Sorry, here the values are minus 2. I have made a mistake here. This is minus 2, minus 2, and minus 2. So the equation will be minus 2. Here it is minus 2. Here it is minus 2. The corresponding equations are minus 2, minus 2, and minus 2. And where are I getting the 2? I get minus 2, minus 2, minus 2, and minus 2. So I will get, here it is 1 plus 2. Here also 1 plus 2. And here it is 4 minus 1. So which is equal to q. So we get x1 by 3 plus x2 by 3, sorry, equal to x3 by 3 equal to k. So we get x1, x2, x3, which is nothing but 3k, 3k, 3k. So it is nothing but 3 times k. If I take it out, I will get 1, 1. And this is the eigenvector for the eigenvalue lambda is equal to 2. So we got 3 eigenvectors. That is, the eigenvectors are vectors are 1 0 minus 1, 0 1 minus 1, and 1 1 1. And these two eigenvectors are from lambda is equal to minus 1, and this is from lambda is equal to 2. That's it.